the presentation for Team 14 for CS 599 consisting of team members Minu, Antriksh, Arpin, and Karina. The purpose of this assignment was to evaluate the content and analysis text retrieval for the polar datasets. First of all, we determined that our MIME type detection is good. We define it to be good when it is fast, accurate, and not based on the availability of any prior information. Based on our analyses from assignment 1, we updated the MIME types in Tika and ran it against the application octet stream files. We were correctly able to identify about 10K octet stream files. We also think our parsers extracted the right text. We define the right text as whether or not the text is relevant to the files and whether or not it has a necessary content. We use the tag ratio algorithm to extract the important text. We noticed that for around 100 HTML files, the text extracted did not have any ads, JavaScript, or jQuery code, but only the important content in the body tag. This first visualization is a cluster dendrogram identifying the path taken from request domain to response domain to the individual URLs that the crawlers arrived at. These URLs can then be expanded to show the NAR that were present on the page. For example, when we click on NSF polar data, it will expand into the various response domains. And then when we click on the arcticjournal.com, we will see the related URLs. And expanding a URL, we can then see the date, money, person, and time NARs that are present on this page. The crawler was also able to find relevant results and pages. We were able to pull a variety of name entities using Apache OpenLP NAR and also suite name entities. The presence of similar NARs across a multitude of the pages indicates that the crawled pages were likely relevant. Now we will move on to our second tab, which is the file size diversity tab. This visualization shows the file size diversity of CSCI dataset by MIME type, with the size ratio of the solar index to the file size diversity normalized to values between 0 and 1 for all files. By navigating to each dropdown, we can see the resulting bar charts for each MIME type, detailing the frequencies for each size ratio. For instance, for application RSS plus XML, we were able to see that the ratio between the solar index and the original file size is quite small. Now we will move on to the text retrieved tab. This is a bi-level partition that shows the plot parser hierarchy versus the amount of text retrieved per file size per MIME type. The amount of text retrieved is the normalized ratio of content obtained from Tika parser. The file sizes depicted here are also normalized between 0 and 1 in the 10 partitions. Tika internally selects the parser call chain to be called depending on the MIME types to analyze whether or not we are selecting the right parser. We examined the parser call chain that we used in both the text metadata retrieved D3. We see that the parser call chain is directly associated with the MIME type. For instance, we saw that for the parser chain default parser, HTML parser, the files that are parsed using the chain were text/HTML and application/XHTML plus XML. We were also able to extract a lot of metadata and text from the files using this parser chain indicated that it is the right parser. Now we will move to the metadata retrieved tab. This is the bi-level partition that shows the plot parser hierarchy versus the amount of metadata retrieved per file size per MIME type. For example, clicking on the default parser, HTML parser division, will pull up the file size per MIME type. Amount of metadata is the number of metadata keys obtained from Tika parser, and the file sizes are normalized between 0 to 1 with 10 partitions. In our visualization for default parser, HTML parser, even for small sizes ranging from 0 to 0.5, we were able to extract 18, 19, 20 metadata keys. This indicates that the metadata fields are relevant and uses standard vocabularies. From an analysis from assignment 2, most of our files had a good metadata score indicating that they were appropriate. We also noticed that some of the files had a low metadata score. When inspected further, we noticed that the description and version field keys were missing in them. Now we will move on to the language diversity tab. This visualization indicates the language diversity amongst MIME types. The pie chart on the right gives a breakdown of file types. To see how well our language detection performed, we looked at the number of languages identified in our visualization, which totaled 28 languages. For example, if you hover over the text/HTML slice, you will see that most of the files belong to the English, Italian, and Romanian languages. Now we will move to the word cloud tab. We use the same word cloud that we generated in assignment 2. It represents commonly used words across the title and description of the files. We see that temperature, heat, national, and mineral are some of the most common words. This next tab is the max joint NER agreement visualization. This bar chart evaluates the maximal joint agreement NER between most frequently occurring entities. The x-axis shows the count of keywords identified by NER, and the y-axis shows the keywords. For example, the employer's media student keyword was identified by NLTK, OpenNLP, and Core NLP. We also saw that Core NLP had a very few intersections with OpenNLP and NLTK keywords. This last tab is the spectrum of measurements, which shows a bar chart of the range of measurements obtained from the NER. The first option shows the spectrum for all measurements across 9 types. For example, for seconds, we measured a minimum of 120 seconds, a max of 2020 seconds, with an average of 540 seconds. In the second option, we focused on the length measurements and their spectrum for HTML and PDF files. The third option shows the spectrum for files from the 7-zip domain. The last option performs an analysis on only the PDF files. To answer the question of whether or not our named entities made sense, we were able to extract the length, mass, temperature, year, date, and time values and their respective ranges. We also obtained person, location, and organization information. We went through the response and saw that the data in each of these keys made sense. For instance, we noticed that the response in NER person and NER dates were actual person names and dates, respectively. In conclusion, we evaluated our content type analysis on the Trek Polar dataset, and we can confidently say that our content detection and analysis made sense and was accurate. Thank you.